I am Jozef Masarik from Komenský University in Bratislava, and I am nuclear physicist with a strong interest in space research and application of nuclear physics and these space research methods in studying the Earth's environment and Earth's climate. So I will speak about three topics. As I mentioned that I am not a climate scientist, so I will speak about the things which I think I know something about. And it is a relations between the sun and the earth, and some data that shows that this relation or the influence of the sun on the earth is varying in the time, and that there is some natural variability in the environment. So the basic picture what we have is based on the relation between the sun and earth. The earth is one of the 8 planets of the solar system, and here are given some numbers that show the distance. This is important from the point of view of the energy input we get from the sun. This energy we get from the sun, we get it in the form of electromagnetic radiation. It means with the photons is irradiated everything on the earth, and these photons are from wide range of wavelengths, and this is important for the discussion of the influence of the sun on the Earth's climate, because depending on the wavelengths, there is a different influence on the Earth, and also different wavelengths influence different species in the atmosphere and on the surface. For example, ozone is very sensitive to ultraviolet radiation. And then we have another radiation, it is particle radiation. I will come to that later. And this radiation from the sun is responsible for that the different part of the atmosphere are heated to different temperature. You see there the temperature profile in the atmosphere near the surface. Then we have the height, and we see that the temperature is first decreasing, then increasing. It depends on the property of the atmosphere, the ability to absorb the heat, and then to radiate the heat either to the surface of the Earth or back in the space. Here is such typical picture that you see where we are on the horizontal axis. There we see the surface of the Earth. These are altitudes at which commercial planes are flying, and higher we have satellites, and here you see the temperature profile, and then you see the density. The density is decreasing, but temperature is varying and increasing. Yes, it depends. This depends on that which part of the radiation is important to which altitude, and the temperature is just some response to the absorption or redistribution, I would say, of the energy what we get. So in the end, the temperature which we measure depends on the latitude, altitude, and then also, and this temperature is a result of the summing of the energy we get from the sun and subtracting from that the energy that is released into the space. Okay, so here is the situation complete, and as I mentioned, besides the electromagnetic radiation, we have these cosmic rays. There are 2 kinds of cosmic rays. There are cosmic rays coming from the sun, so-called solar cosmic rays, and cosmic rays coming from the center of the galaxy, galactic cosmic rays. These particles are not very important from the point of view of the energy they are bringing to the atmosphere. Yes, because as I will show it later, this contribution is pretty small, but as was mentioned earlier, these particles can play important role in influencing the cloud coverage, and the clouds influence the global temperature on the Earth pretty much. So, here we have some summary of that, what we are getting from the sun, which kinds of energies, and you can see on that spectrum of electromagnetic radiation what part of the energy, or what is the value in the watts, what we get from the sun on the Earth's surface. Yes, so we can see all the sources, and as I mentioned, the contribution from the particles, which is in that pink, is pretty small. Then what I didn't mention till now, there are particles called solar wind. These are, again, not so important from the point of view of the energy input, but they play a very important role in the modulation of cosmic rays, and they are influencing also the geomagnetic field, which also plays some role in this relation between the sun and Earth. So let us go to the next topic, the variability. The variability of the solar intensity can be expressed in different ways. One of the oldest one is describing the solar activity using the sunspots. The sunspots are places on the sun which can be visible very easy, that can be counted. It started a few hundred years ago. And these sunspots are related to the solar activity. When you have many sunspots on the sun is active. When you have fewer of them, the sun is quiet. And we know with high precision how this number of the sunspots is varying in the last period. Here is a picture which gives this information within the last 30 or something like so many years. We see the variation in the number of the sunspots. There are these numbers 21, 22, 23. It means the cycle, solar cycle, 11-year solar cycle, which is marked with these numbers. You can see that the number on sunspots is varying from almost zero, what was typical for Maunder minimum, and so to about 350. So this is pretty wide range. But there is still not answered the question how this number of the sunspot is related to the output of the energy from the sun, or how it is related to our climate. But we can get to that later. These sunspot numbers are also related to the magnetic fields of the sun, which then influence the fluxes of other particles, and the magnetic field of the sun interacts with the magnetic field of the Earth. We know many kind of the variation of the sun. I showed here just the shortest one. 5 minutes variation, yes, 27 days, 11 years. Then we know 86 years, 207 or 210, and the longer cycles. So we can say for sure that sun is a very variable star, and therefore this variability have somehow to influence